You got the velocity, you got the magnetic field. The force on a positive charge would be into the board, but this is a negative charge, so it's out of the board. You have to reverse it. And if that's a 90-degree angle, QVB. Sine of 90 degrees is 1. Okay, so you're getting the idea here that we're now dealing with 3 dimensions a lot. We're forced into that because V and B are going to lie in one plane, and the force is perpendicular to that plane, so we have to deal with 3 dimensions. So we need a way of differentiating into the page, out of the page, and what we use are dots and X's. And the way you remember this is you picture an arrow, like a bow and arrow, an arrow. If the arrow is coming out toward you, what do you see? You just see the tip of the arrowhead coming toward you. If the arrow is going away from you, you see the crosshairs, the feathers right on the back making the crosshairs. So this is something going away from you. This is something coming toward you, into the page, out of the page. And then what we have to try to avoid is using the word down and up, meaning top of the page, bottom of the page. So I'll try, sometimes I'll slip up. I'll try to say top of the page instead of up, and bottom of the page for down, and into the page and out of the page, or into the board and out of the board. So up and down is kind of meaningless, right? But if your paper is flat on your desk, up and down means a different thing than when it's on the board here. So I'll try not to use up and down. I'll try to use top of the page, bottom of the page, into the page, out of the page. So here we have a magnetic field into the page, velocity to the right. What direction is our force? Towards the top of the page. I'll draw it in red here. Is that right? And what would the value be? QVB, right? Because they're 90 degrees apart. Okay?
I have a question on T. When I was looking at
you got it? Okay. How about this one? Direction and the magnitude. Here's in the direction of V. Roll them towards the magnetic field. Your thumb points along the axis of rotation in the direction of the force on a positive charge. So sort of up and to the left there at a 90-degree angle. How's that? And what's the magnitude? What's the angle? What's the angle between? This is the angle between V and B. Right? B is perpendicular to the page. V is in the plane of the page. There's a 90-degree angle between them. Doesn't matter that it's pointed this way or that way. As long as the velocity is in the plane of the page and B is perpendicular to the page, there's going to be a 90-degree angle between the velocity and the magnetic field. Let's see. Negative particle moving into the page B to the right. Okay, what direction? H, what direction do we get? Towards the top of the page, right? Because it's a negative particle. V is in, and B is to the right. So V is in, B is to the right. A force on a positive charge would be down, but we flip it 180 because it's a negative charge. So up towards the top of the page. And the magnitude would be QVB. I guess I should, for these negatives, I should put, all I care about is the magnitude here. I get the direction with my right-hand rule. And the last one here, V going towards the top of the page, B coming out of the page, because it's a negative charge. V is up towards the top of the page, B is out of the page. So for a positive charge, the force would be to the right. This is a negative charge, force is to the left. And they're 90 degrees apart, right? So the force QVB sine 90 degrees is 1. Okay? That help a little bit?